Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So it's my turn now to give a talk on the seminar, BioNanoTechnology seminar. So one of the important thing is the uh, nanoparticles, and in my part is immobilization of nanoparticles. Actually, the term immobilization is come from the word mobile, moving, and mobile. So immobilization is not moving, tak bergerak. Immobilization. So immobilization ni can be encapsulation, can be incorporation, can be absorption, and many things. So immobilization ni is a term, is a general term. Sometimes we do not know the mechanism, whether it's encapsulate, is absorbed. So we just use the term immobilization. Sometimes we use incorporation. So it's depend on the mechanism actually. So the term immobilization is very general. We can say that is immobilization. Because actually I have experience. I said one nanoparticle encapsulate onto other particle, and when I send a paper and the examiner asked to prove that the particle encapsulate, the term encapsulate is like a put it in capsule, encapsulate inside the something. So we cannot prove it, so we just say it is a incorporation. So the term is also important. Okay. And then if you try to find the literatures on immobilization of nanoparticle, you will find that there is a lot of immobilization of enzyme on nanoparticle, or immobilization of something onto nanoparticle. And nanoparticles, they use as immobilizer. But this one, I want to talk about the immobilization of the nanoparticle itself. So that's different things lah. Okay. So this is the content of my presentation, starting with the fundamental, needs, approach, summary. Okay, we'll go to the fundamental. So I will give a little bit brief information on this fundamental of nanoparticles, because it has been covered by Prof. Mustafa. So we know that nanoparticles, the size of the materials is in nanometer. So if you can see here, okay, this is the, I think this is carbon, okay, and blood cell also is a bigger, is higher than the nanomaterial, and it's basically based on this particle, diameter of the particle. Okay. So nanoparticle can be divided into organic or inorganic nanoparticles. So the example of organic nanoparticles are polymerase nanosphere, polymerase nanocapsule, liposome, dendrimer, and there is also inorganic nanoparticles, which is mesoporosilica nanoparticle. It is made by silica, SiO2, a carbon nanotube, carbon C, iron oxide, Fe2O3, gold nanoparticle, and quantum dot, and also silver nanoparticle. Okay. So this is the silver nanoparticle that we obtained from Kesum leaf. This work by Nabihan. Okay. And we got this silver nanoparticle after 24 hours of the reaction. This actually has been optimized in the lab. Okay. And we got this, the size of the particle is in nano size, using TM here. Okay, but it's heterogeneous, not homogeneous. Okay. And this just want to show you that the silver nanoparticles, okay, from Merck, from the commercial nanoparticle. So the particle also, the morphology you can see here is in the form of spherical, and the size of the size also is very small, in the 100 nanometer. Okay. Well, actually, in terms of the antibacterial, antimicrobial mechanism of silver nanoparticle, so this is actually still ongoing. Okay, the mechanism, there is no exact mechanism of antimicrobial or antibacterial activity of silver nanoparticles. Some say that it is come from the release of silver ions into the solution or into the medium, and these silver ions, Ag plus, kills those bacteria. Okay, and how Ag plus kill the bacteria also still in debate actually. Okay, because in reality, and microbe ni microorganism. Okay, microbes including bacteria, virus, fungus, and so on. Okay, and bacteria is very specific. Bacteria only. Bacteria also we have a lot of species of the bacteria. There is also thermophilic bacteria. There is also marine bacteria. Bacteria from apa nama tu? In our body, and so many types of bacteria. So each type of bacteria they have their own defense mechanism. Okay, they have their own what do you call it, cells, membrane, and so on. So each of the silver uh, antibacterial mechanism is still debating, and if we come up with trying to get information on the mechanism is still relevant nowadays. Okay, it's still relevant nowadays. Okay, but the common one is that the Ag plus silver ions breaking through the cell wall of the bacteria, and then after that the silver ions disrupting the respiration of the microbe, and silver ions attached to the DNA of the microbe and stop cell replication. So this is the common one lah, antibacterial. Okay, silver nanoparticle ni, sometimes we call it antimicrobial, sometimes we call it antibacterial. So which one we want to use the term? Which one we want to use the term, antimicrobial or antibacterial? Okay, if for example in your experiment you focusing on bacteria only, and it's better for you to come up with antibacterial agent. Okay, and you make sure that the whole thesis ke the whole paper just focusing on antibacterial. Okay, but if you are focusing, if you have done this experiment, the antimicrobial assay, not just only bacteria, you have done this against fungus, against yeast. So you can come up with the term antimicrobial, and you can use that term antimicrobial for the whole thesis, for the whole paper. Because because I saw that in some of the paper also, they come up with inconsistent term. First paragraph, they call it as antibacterial, second antimicrobial, and then antibacterial again, and so on and so on. So please stick to one. Okay. So for this project, this program is about antibacterial wound healing agent, not the antifungal wound healing agent. Antifungal is different. Okay. Okay, so there is also problem with nanoparticle. Also, it has a good activity, like what Prof. Mustafa said, that the smaller the size of the particle, the activity will be much better because of the higher surface area, because of the lowest the size. But actually, because of that reactivity, it also has a problem. This nanoparticles. Not just only focusing on silver nanoparticle, but also other nanoparticle. For example, like titanium dioxide nanoparticle, TiO2 nanoparticle, gold nanoparticle, organic nanoparticle. They also have a problem because it's too small. In terms of safety issue, it can penetrate to our skin. Okay, once it's penetrated to our skin or inhale, and it can be accumulate in our body, and it actually affect our cell or organ. Okay, and then in terms of surface area, because of high surface area, it's actually reactive as compared to the micron size of the particle, and then it can create secondary or tertiary problem, which is environmental pollution, or bacterial or microbial resistant issue. Okay, you can say that aggregation of silver nanoparticle ni create secondary, which means it has already a problem, and then when we use it in large scale, it will create secondary or tertiary problem, which is related to the application of the nanoparticle. And this is also some of the problem, like what Mustafa said that, okay, these nanoparticles tend to aggregate or agglomerate. So for the aggregated, these are the aggregated particles, and this is agglomerated particles, which means that the small particle, nano-sized particle, become larger. Okay, so this is one thing that we need to we need to solve. So that's why one of the things that we can solve is by adding camping agent, by adding as a vector, adding mycel and so on. Or we synthesize it using plant extract, and inside the plant extract there is phytochemical compounds, which is organic compounds that can become capping agent. Okay. So one thing that we can do to solve this problem, okay, because of the safety issue, because of the secondary or tertiary problems related to pollution. So what we can do is that we still can use nanoparticle, but the amount of nanoparticle can be controlled. Amount can be controlled, and then the release also can be controlled. There is also term, we call it drug delivery system, okay, or control release system, where we have a particle, we put it on other particle, and this particle will control the release of this particle. Either we call it control release system, uh, drug delivery system, or slow release system. Okay, the system, slow release system. So in this paper, okay, by Morris and Gasquet here, they classified this support system, or we can call it as a support system. It's actually familiar with informatical. Okay, during my PhD, I'm studying about drug support system. We use a zeolite to support this aspirin. Aspirin is one of the anti-inflammatory drug. So we use support system. So these are the support, example of the support system that we can use to immobilize nanoparticle. Nanoparticle, okay, for example, like nanomaterials, hydrogels, other support system, for example, like micelle, carbon particle, mineral, and inorganic materials, for example, monolinolide, vermiculite. So these are all mineral. These are all clay and modified class. Hydroxyapatite or silica particle, or synthetic polymer. Okay, synthetic polymer, silicon elastomer, PVP, and also natural fiber or biopolymer, or silk cotton, natural fibers, or nanofiber. Okay, where you have done this using electrospinning, right? So those are the method that we can use. Those are the materials that we can use to immobilize nanoparticle. Okay, remember in this term I want to discuss about immobilizing nanoparticle using other material. Okay, because nanoparticle also can be used to immobilize other compound. Okay, understand? Okay, so this paper also come up with the this diagram. It's a good diagram here, actually, to show that these are the nanoparticle that they incorporated into different material, and these nanoparticle tend to scatter the position or the place where this nanoparticle mobilize. They are all scattered, which actually prevent this for the agglomeration or aggregation. Okay, for example, like fiber, the fiber. So this is example of fiber, and these are the nanoparticle here. Nanotube inside the carbon nanotube. So the location of the nanoparticles are all scattered, and inside the fiber particles. Okay, modified surface, matrix lump, functionalization, and so on. Okay. So this is one of the idea. That's why one of the project in my program, in the big program, is the um, green silver nanoparticles immobilized on synthesized zeolite. So for the progress of this project, this will be covered by my student, Mr. Haris, after this. Okay. I want to talk about zeolite. So one of the good support system is a zeolite. So this is one of the expertise. So zeolite is actually hydrated aluminosilicate. It can be in the form of synthetic and also natural. It can be found in volcanic area. That's why we don't have in Malaysia. In Malaysia, we don't have volcanic area and we don't have zeolite. Because of that, we don't have zeolite. Okay, we can get actually this zeolite from Indonesia. There is a lot of mineral deposit around volcanic area. Not from the lava, but from the soil. Okay, from the surrounding soil, because it's involved the synthesis of this silver. The synthesis of these zeolites is based on the hydrothermal technique. There is water and also temperature hydrothermal technique. Okay. Zeolite ni there is a lot of family of zeolite. We call it a family of zeolite because they have same framework. Okay, the same framework. For example, like this one is for the zeolite A, they call it LTA, Linde type A. It's a synthetic zeolite. And this one, actually I forgot. Okay, I think it is a clinoptilolite, carbazite and so on. There is a lot of families of the zeolite. Okay, there is also synthetic zeolite, there is also natural zeolite. Okay, there is zeolite A, zeolite X, zeolite Y, zeolite beta, zeolite and so on. Okay, there is also the name of the mineral. Clinoptilolite, modernite, carbazite, and inilah the name of the. If you see the name there, clinoptilolite, there is IE. So IE there is stand for the mineral. Paugesite is come from the mineral paugesite. So there is a montmorillonite. Montmorillonite is one type of the clay. So there is a IE there. So those are the name for the mineral. If in biology they have species and genus, in mineral also they have that name actually. Okay. So this is zeolite morphology. I got it from Nabihan. So we synthesize Nabihan synthesized this zeolite from kaolinite, and actually we got this zeolite A, which is in the form of three-dimensional, in the form of crystal. Kalau kaolinite itu, clay is in the form of layer. There is no specific structure, but when we synthesize it in zeolite, there is a in the form of crystal. So this is one of the unique property of the zeolite. Okay, zeolite ni it has a pore. It is in the form of crystal. It has high stability. Okay, it's composed of aluminosilicate. It has a high surface area. It has cation exchange capacity, CEC capacity, and so on. So because of this, we can use this to immobilize silver nanoparticle. Okay. These are some example from previous studies. So I will go not much paper studies on the immobilization of silver nanoparticle on zeolite. Okay. So just only 4. That's why we are trying to improve the technique of immobilization, especially using plant extract. Okay, based on this paper, okay. So what they did actually from Shamini in 2011, what they did actually they enrich the zeolite structure with silver ions, okay, and then after that they use sodium borohydrate as a chemical reductant to reduce this silver ion into the silver nanoparticle. So at the end, they got the silver nanoparticle inside the silver ion. Okay, and then they did on antibacterial testing. Okay, for the other paper, they put this zeolite on top of the alumina substrate, and then it will be it's actually become zeolite membrane on alpha alumina substrate, and then ion exchange with silver nanoparticle. So the product now contain silver ion, and then reduce it using hydrazine, And the zeolite membrane is now contain nanosilver. So they make sure that the silver enriched inside the zeolite. This one, because zeolite can capture those silver ions, and then the silver ions will be reside inside the zeolite structure or zeolite framework. And after that, they use a chemical reagent, chemical reducing agent to reduce silver plus to silver ion. Silver ion to silver nanoparticle, silver zero. Okay. This is another one. Okay, in 2014. Okay, they compare it with silver ions and also silver nanoparticle in zeolite A composite for antibacterial activity. Okay, so they show that these are the AgNP and these are the zeolite structure, zeolite framework. Okay. Okay, so from actually there are 4 papers on this. Okay, I summarize in this table. So the type of zeolite that they use, zeolite A, zeolite Y, and also zeolite A. Because zeolite A is actually easy to synthesize, is much more stable as compared to other zeolite. There is also zeolite Y, zeolite X, but sometimes if we synthesis this zeolite in the lab, sometimes we want to synthesize zeolite Y, we get zeolite A. Sometimes we want to synthesize zeolite X, we get zeolite B. So because it's unstable. Especially if the precursor is come from the natural clay, which there is a lot of impurities inside the raw material. Okay. And then most of the paper here, they actually enrich the zeolite structure with this Ag+, and then after that they reduce it to silver zero, silver nanoparticle, using chemical reduction or some of them using heat treatment. Okay. So I go to the summary. Okay. So the summary. So this is schematic diagram showing that the immobilization of nanoparticles. If there are no immobilization or if there is no support material, they tend to agglomerate or aggregated. But if you put this nanoparticle inside support material, so the nanoparticles, nanoparticles here, the blue one here, okay, they are actually scattered inside the support material. Okay, so for the summary, nanoparticle has a various application and high activity because of the high surface area, because of the reactivity. However, there are problems with the nanoparticles such as toxicity, in terms of reactivity and also agglomeration. Okay, and the nanoparticle can be immobilized onto suitable support system, for example, like immobilization of silver nanoparticle on synthetic zeolites. Okay, so this study is still ongoing, and for the results, Mr. Haris will give a detailed result on this. And thank you very much for the. I would like to acknowledge UTM, TDR, CSNano, Department of Biosciences, and also the Department of Chemistry, and all of the students. So with that, thank you very much.